Okay, so today we're going to be doing a little bit of thermochemistry, a problem with energy conservation. It reads, a hot air balloon is being inflated to its full extent by heating the air inside it. In the final stages of this process, the volume of the balloon changes from 5.0 times 10 to the 6 liters to 5.40 times 10 to the 6 liters by the addition of 1.4 times 10 to the 8th joules of energy as heat. Assuming the balloon expands against a constant pressure of 1 atmosphere, calculate the change of energy for this process. Okay, so we know that the formula for this right here is delta E equals Q plus W, where Q is heat and W is work. Well, in this problem, let's identify what is the work and what is the heat. Well, right here, it clearly states by the addition of 1.4 times 10 to the 8th joules of energy as heat. So we know that Q is 1.4 times 10 to the 8th joules of energy. But in this, it says nothing about how much work is being done on the system. So we're going to have to find out what work is in order to complete this formula to get the final answer. Well, we know that the formula for work is negative P delta V, which equals negative pressure times the change of volume. Well, that's easy because we could figure this out because they give us the changes of volume right here, and it gives us ATM, which is basically the pressure. It says it's one pressure, like 1 atmosphere of pressure, and right here it tells us the change. So I'm going to get my calculator, and I am going to type in the final volume, which is the 5.4, minus the initial volume. The initial was 5.0. So I'm going to do this right here. I'm going to go 5.4 times 10 raised to the 6th power minus 5.0 times 10 raised to the 6th. That gives me 400,000. Of course, we want things in sig figs just because it makes our life easier, even though it does look more complicated. So I'm just going to write that down. We have as 4.0 times 10 to the, and then we count after the decimal point, 1, 2, 3, 4, 5. So I'm going to go ahead, since we're trying to figure out work, let's try and keep things organized. So work equals negative P delta V. So now we know that this change, that's what delta V means. Delta is basically the change of volume. Or delta basically means change, and then V in front of it is volume. So we figured that that was 4.0 times 10 raised to the, let me see, 4.0, 1, 2, 3, 4, 5. So 10 raised to the 5th. Okay, so now we are going to, now that we have this part, we need to figure out what the pressure is. Well, that's simple because right here in the problem, they gave us the pressure, 1.0 ATM. ATM is a unit of pressure. So all we have to do is multiply, and because there's a negative, you always want to make it negative, that pressure that they gave you. So now we're going to multiply negative 1.0 ATM times 4.0 times 10 to the 5th. Well, then, you know, that's easy. You don't need a calculator. Basically, that just turns our problem negative. All right. So this, my friend, is our W, and that's what we needed. But there is a problem because the delta E equals heat plus work. Heat is in joules, and we need these to be in the same unit. And we saw right here that the heat is 1.4 times 10 to the 8th joules. So I'm going to write down 1.4 times 10 to the 8th joules plus this number. Unfortunately, we need this to be in joules. So in order to do that, we have to get this 10 to the 8th times 101.32 joules over, it's going to be over liters per atmosphere. This basically cancels out this liters per atmosphere as well, or ATM, sorry. And it's all about getting this to joules. So now we're going to do our negative 4.0 times 10. E is basically another thing for 10 times 10 to the, and we figured it was to the 5th. And now we're going to multiply that by the 101.32 joules. In turn, it gives us negative 405, or actually more than that. It gives us this large number, so of course we want to do our sig figs. We always want to put our decimal place one about right here. And there's 0.5. We're going to go ahead and round up to negative 4.1. So if it's right here, there's going to be 1, 2, 3, 4, 5, 6, 7 sig figs. So now we have this answered. Our W turns into negative 4.1 times 10 to the 7th joules. And now that our units are matching, we could now go over, take this, and just plug it right in there in the formula. And it's going to be negative 4.1 times 10 to the 7th joules. And that is going to give us, let's see, 1.4 times 10 raised to the 8th power plus negative 4.1 times 10 raised to the 7th. And that gives us this ginormous number. So we're going to put it in sig figs. We're going to do 9.9. So I'm going to write that down right here. So 9.9 times 10. And we're going to count. 1, 2, 3, 4, 5, 6, 7. Times 10 to the 7th joules. So this is the answer. And if you want to be clear, you could write delta E equals 9.9 times 10 to the 7th joules. And your professor or instructor cannot get mad at that because you're being very specific. And that's exactly what the question was asking. Hope that helped.